The visual part, remember we have this property whenever we have a triangle.
Okay.
Okay. And then this angle is exterior angle. Right?
Okay, so here we go. Let's start with Kranji first.
Of the two interior angles.
Okay, everyone got your papers out and ready?
This is B, right? And this angle is C. So A plus B will be equals to C. Okay, so that's what's happening.
Okay, great.
Also. Right, this exterior angle 1.2.
So let's begin. So
the two interior angles.
Question number 1. Okay, so at any point in time, if you're not sure about anything, just ask, okay? Because I may not be able to see you raising your hand. So if there's anything you're not sure at any point in time, just ask, all right? So step number 1, how to read a vernier caliper. Sorry, this is a micrometer screw gauge. So step number 1, you have to know that this is 0, this is 1, this is 2. And in between 0 and 1 is 0.5. In between 1 and 2 is 1.5. And this is 2.5. So I know it is 2.5 something. Okay, so this is the something that I need to find. And since this is in line with this fella, 30 is what I want. Okay, so I have to add 0.30, which will give me 2.80 mm.
What's the question?
Okay, so therefore the answer is B.
When? Okay, only when
all right.
The question states so. That means when the question clearly
okay, second, pendulum. So I'm just going to go through and I'm going to talk through my thought process. So in this case, it's in a way helping you to revise how to approach these sort of questions. Yeah. Okay, so pendulum. The time taken for a pendulum to swing from P to Q is 0.3 seconds. Okay, so this is 0.3 seconds. Now, one complete oscillation is 1, 2, 3, and 4. So one period is actually 0.33 times 4 because there's 1, 2, 3, 4. And this will give me 0.33 times 4. This gives me 1.34 seconds. So this is one period. Now they are saying how many complete periods in 2 minutes. All right.
Wait, sir. Now why is it 0.33?
Huh? Come again?
Why is it 0.33?
0.30.
Oh, sorry, it's 0.30. My bad. Wait, 0.3 times 4 is 1.2. Sorry. Thank you for raising that up. So it's 1.2 seconds. Okay. So therefore, in 2 minutes, how many periods do I have? So I have to take 120 seconds divided by 1.2 seconds. Okay, which gives me 100 periods. So the answer is B. All right. Okay, next question 3. Okay, so on Earth, a ball is dropped and falls 2 meters. So this is the distance it falls. The acceleration of the ball over here, the acceleration is 10 meters per second square. What is the acceleration of the ball at 0.5 over here? What is the acceleration? Okay, so this one, it attempts to trick you by giving you a lot of information. Okay, it attempts to give you a lot of information, 2 meters, at 1 meter, so on and so forth. But the key here is that gravitational acceleration in Earth or on Earth is always 10 meters per second squared. So it's always 10 meters per second squared, no matter where you are. So the ball could be here, the acceleration is 10. If the ball is here, the acceleration is still 10 meters per second. Okay, so there's nothing to calculate. You just need to know that acceleration on Earth is always 10 meters per second squared. Okay, question 1 to 3. Any questions?
Because I'm looking at this segment, the blue one.
Take that as a no.
For the blue one.
Okay, a boat is traveling at uniform speed. I'm going to underline this. I don't know what the question is asking, but once I see uniform speed, I'm going to underline it straight away. Okay, in a straight line across the surface of the lake. Now, which statement is correct? The resultant force is in a direction of motion. In this case, I'm going to KIV first, because when I see uniform speed, straight away, I know that the resultant force is 0 Newton. Okay, so there's no resultant force. So I'm not sure about this statement yet. The resultant force is in the opposite direction of the motion. Now, this is clearly not true. This is clearly not true. If it's in the opposite direction, means it's slowing down. Okay, so this is not true. The resultant force is greater than the resistive force. This is also not true. The resultant force on a boat is 0. Yes, this is true. Okay, so therefore we can eliminate this, and this one is the most correct answer. Okay, so the answer is D. So straight away, when you see uniform speed,
so the area of this
when you see uniform speed, straight away, you must be able to tell in your head that the resultant force is 0 Newton. And in some other questions, you must also know that the acceleration is 0 meters per second square. Okay.
The area of this sector, the blue one.
Okay. Two students are in a lift that is accelerating upwards. Accelerating upwards, okay? The total mass of the students and the lift is 400 kg. So straight away, I know that there is going to be a downward force of 4,000 Newton. Anyone here needs to know why or how I got 4,000 Newton? Please ask. Okay, so I assume you all know this one times 10, yeah, to get the downward force. The tension is 5,000 Newton. So the tension means it's the force in the cable. The force in the cable is 5,000 Newton. Okay. So they're asking for the acceleration. Therefore, I'm going to use the formula FR equals to MA. You must know, remember how to use, remember this formula and know how to use it. Okay, the resultant force is this fella. minus this fella.
So I just need to take the blue
The mass
area minus the
is
orange
400
area. Then I'll find out the area of the shaded region. So that's the last
times
part. Area
A.
of the sector OPQ minus
Therefore,
area of OPR.
A
Then you get 8.95.
is 5,000 minus 4,000 divided by
This
4
question, if they give you
is 2.5.
Paper 2 question. I would say, because first time we're doing it.
So the answer is A.
You get the hang of it. Okay. Concept wise,
Okay.
it's not difficult. It's only because you are having two overlapping arcs.
Okay, next.
Much more visually challenging.
This is balanced. So it is balanced. That means it's not going to fall over, but it is just about to fall over. So I know that C and D cannot be the answer. If C and D is the center of gravity, the line of action is going to force this fella to topple over in a clockwise manner. Okay, but of course that's not happening. So therefore C and D is not the correct answer. It cannot also be A. It can't be A because this means that this one is very stable. Okay, it's very stable. The line of action is in between the base area. So it's very stable. So it cannot be A as well. Therefore, the only answer is B, because this fella, the line of action is just at the edge of the base area. So it's just about to fall. Therefore, the answer is B. Okay? I'll stop here. Question 4, 5, 6. Any questions you might have?
For those who are attending is Sean, Jinser, Max, Lucas, Hasim, Joshua, Josiah, Timothy, Lucian, Raymond, Calvin, Dylan.
Okay, I'll take that as a no. Okay, so next we go on to evaporation. Okay, evaporation. Why does evaporation occur? Okay, evaporation occurs because the liquid cools, because liquid molecules have more potential energy than gas molecules. That's not really why. Okay, the liquid cools because faster moving molecules escape. Yes. Okay. And since the faster moving molecules escape, the overall energy of the liquid will drop. That's why the liquid cools. Okay. The liquid will not warm up. Okay, the liquid will not warm up, it will only cool down. So this is one of the characteristics of evaporation. The body of liquid left behind cools. Okay, so this is one of the characteristics. It's always a cooling effect due to evaporation. Okay, so the answer is B. Can? Okay, next, what is the maximum pressure? So they're not just asking you to find pressure, they're asking you to find maximum pressure. So to find the maximum pressure, first of all, you need to know what is the formula for pressure, which is force over area. So that's the first important thing you must know. Second important thing, to find maximum pressure, I need to know that the area must be the smallest area. So in this box, I've got three areas, right? I've got area X, Z, Y. The smallest area seems to be area y is 4 times 6. Okay, the rest will give you bigger area. So the smallest area that I want is area y. So therefore, I have to place the box standing on this area. Okay. So the maximum pressure is force over area. The force is not 500 grams. It is not 500 grams. I have to change this fella to Newton. So to change this fella to Newton, I have to first change him to kg. So divide by 1000. 1, 2, 3 gives me 0.5 kg. Okay, and then to change this fella to Newton, I times 10. This gives me 5 Newton. Okay? So I know the force is 5 Newton. If I look at the final answers are given in cm square. So I'm not going to change all this to meters. I'm going to leave it as cm square. So it is 4 by 6. It's 4 times 6. Okay, so you press your calculator. I'll get 0.28. 208. And B is my answer. Okay. Okay, I pause here for a while. Question 6, 7, 8. Any questions? See, for some reason I can't really see all of you, so I can't see whether you are raising your hands or anything. So if there's any questions, you have to just unmute yourself and speak up. Okay. Okay. Let's move on to question 9 then, if there are no questions. Okay. What is the work done against the force of gravity? When you see this against the force of gravity, means we are talking about the upward motion, because gravity is always downwards. So now we are talking about the upward motion. Okay, this is what it means, against the force of gravity. So if some of you are confused, like, I know what work done is, but I don't understand what does against the force of gravity means. What this means is that we are talking about the upward motion. Okay. So now, I'm going to just consider this distance, not this distance, because it's upwards. So I'm only looking at this distance. So work done is force times distance. Okay. The force is not 60 kg. The force is not 60 kg. I have to change this into Newton. So therefore, if his mass is 60, his weight must be 600 Newton. Okay, and if the downward force is 600 Newton, that means in order to lift himself up, the upward force must be at least also 600 Newton. So this is the upward force he has to exert to move his body up. So therefore, it is 600 Newton. Okay, and the distance he moves in total is 1.5 meters. All right, press your calculator. This should give you 900 joules. So the answer is C. Okay. Okay, question 10. Okay, a ball rolls down a frictionless ramp. Okay, frictionless. That means there's no friction. The mass is 1.5 kg. Over here, the ball has 5 joules of Ke. Okay, it's got 5 joules of Ke. How much Ke does the ball have at Y? So over here, what is the kinetic energy, right? So the Ke here, they say, is 5 joules. But of course, the ball does not only have Ke, okay? The ball has got some other form of energy. Can I ask, okay, so maybe I ask Clayton. Clayton, if you can unmute yourself. What other form of energy does the ball have at this moment? What do you think?
What?
Okay,
Wait, what do you
Clayton.
ask? Yeah.
Okay, so the ball here, they say, has got some kinetic energy, right?
Yeah.
They say there's 5 joules of kinetic energy here.
Yeah.
But I'm saying the ball has got more than just this Ke. It's got some other kind of energy. What other kind of energy does it have?
Is it GPE?
Very good. So it's got GPE as well. Okay. So I know over here, as it's rolling down, it's got Ke, but because it's also got a height, it has also GPE. So now I have to calculate what is this GPE. Formula for GPE is mgh. The mass of the ball is 1.5. G on Earth is 10, and the height it's got is 2. Okay, so this is 30 joules. All right. So this is 30 joules. So this is the total energy, 35 joules, 30 plus 5. Right. So this is the total. Over here, they ask, what is the Ke? Ke is also going to be 35 joules, simply because all the GPE is no more here. There's no more GPE because there's no more height. But it doesn't mean that all the GPE disappears, right? Conservation of energy tells us that GPE will be converted to kinetic energy. That's why all the 30 joules is now converted to Ke at the bottom. So the total is actually equals to the kinetic here. Okay, so the answer is 35. Answer is D. Ken? Any questions? Okay, if not, moving on. Okay, I have a student. He stands 240 in front of a cliff and bangs 2 pieces of wood together. A timer records the echo 1.5 seconds after the woods are banged together. What is the speed of sound? Okay, so for me, I always like to draw a diagram. So this is the fella. This is him banging the wood. And this is the cliff. Okay, so the sound goes there and the echo comes back. Okay, and the time taken is 1.5 seconds. Okay, the time taken is 1.5 seconds. His distance to the cliff is 240 meters. So by now, you should know that I'm going to use the formula speed equals to distance over time, right? But because this is a question on echo, so echo means that the sound travels there and the sound travels back. And because it goes there and back, the distance traveled is 2 times. So the formula I'm going to use is speed equals to twice the distance over time. Okay, so twice the distance is 2 times 240 over time is 1.5 seconds. Okay, so let me press the calculator. And you'll have 320 meters per second. Okay, so that's your answer, B. All right. Okay, next. A sound wave travels from one medium to another. Its wavelength increases. Okay, its wavelength increases. Now, the sound wave, as it travels, usually the frequency stays the same. Okay, now why is that so? The frequency is actually based on the source, usually. Okay, so let me write it in full. The frequency stays the same because usually the frequency depends on the source. So if I'm clapping or if I'm speaking, the source matters in creating the frequency. All right. So right now, if I'm going to use V equals to F lambda, this formula, all right, they say that the wavelength increases. Okay, the wavelength increases. The frequency I just told you stays the same. So in order for the left-hand side of the equation to be the same as the right-hand side of the equation, if the right-hand side increases, means that the left-hand side must also increase. Okay, so the frequency stays the same. The speed increases. So the answer is D. Okay. I pause here for the last 3 questions. Any issues any of you have? Okay. Take that as a no. Then let's move on to question 13. Okay, so this is a sound wave. Okay, C stands for compression, R stands for rarefaction. Which of the following is true? All the particles on one line move in the same direction at the same time. This on the surface sounds correct. So I'm just going to KIV this. Okay, I'm going to KIV this. Next, the direction. Oops. What did I do? Okay. My bad. Okay, here. The direction of travel of the sound wave is parallel to the lines. So the direction of the travel of the sound waves is parallel to the line. So what you're saying is that the sound travels parallel to these lines. Okay, that's what you're saying. But we know that's not true. Sound is a longitudinal wave, and therefore the wave will travel here. Okay, so B is wrong. Now let's look at C next. The distance between a compression and an adjacent rarefaction is a wavelength. So this is what you're saying. Between a compression and the adjacent rarefaction is the wavelength. Okay, but we all know that's not true because one wavelength is from compression to the next compression. So this is one wavelength. So therefore, what they've described is just half the wavelength. Okay, so therefore, this is also not correct. The pressure at R is greater than the pressure at C. But this is not true because we know that the pressure at the rarefaction is smaller than the pressure at the compression. So this is not correct as well. So statement A, which I thought was possible, is actually correct. Okay, so the answer is A. Ken? Okay, next. Circuit shown is switched on for 1 minute. How much charge passes through the 3 ohm resistor? Charge is Q equals to IT. Okay, charge is Q equals to IT. So this is the formula you must know. You must remember this formula. But the problem is they did not give me the current. Okay, I stands for current. Q stands for charge. Okay, they want me to find charge, but they did not give me the current. However, they did give me the voltage and the resistance. And I can find voltage, resistance. Using that, I can find the current using Ohm's law. Okay, so this is another formula you must be familiar with. So the current is the voltage over the resistance. Okay, so let me replace the I with V over R. Okay, so it's V over R times time. The voltage is 6. The resistance is 3. The time is 1 minute. However, I have to convert this 1 minute to seconds. So it's times 60. All right. So you press your calculator. 60 divided by 3 is 20. 20 times 6 is 120 coulomb. So the answer is C. Okay. Okay, next, I've got a battery, 3 resistance, 1, 2, 3, and 3 voltmeters, 1, 2, 3. What are the possible readings of voltmeter 1, 2, and 3? Okay, first, let me see whether they are identical resistors. I'm going to assume that these are identical resistors. Okay, why I'm assuming that is because I know if these two are placed in parallel, if these two are placed in parallel, the overall resistance of these two, the overall resistance will be smaller than if it was just one. Okay, if you don't believe me, you can go and calculate by yourself. You can give yourself any number. So if this is 5, 5, you calculate the effective resistance is always going to be lower than 5. If this is 10, 10, the effective resistance is always going to be lower. Okay, so this is one property that resistors in parallel have. The total resistance is always going to be smaller than the individual one. So by virtue of the fact, I know this resistance over here is going to be smaller than this resistance over here. And if this resistance over here is smaller than this resistance over here, the voltage needed for this smaller resistance, the voltage needed here is going to be smaller than the voltage needed here. Higher resistance means voltage across it is greater. Okay, so I know that this voltage will be smaller than this voltage. Next thing, this volt and this voltmeter will give me the same reading because voltage across parallel resistors Okay, voltage across parallel resistors are the same. Okay, can? So this volt and this volt will be the same. Okay, so let's look at the option. So I know I'm looking for voltmeter 1, voltmeter 2 with the same number. So this is 2, this is 2. Yeah, that's possible. This is 2, this is 2. Yes, that's possible. This is 2, this is 4. So already I can cancel out this. This is 6, this is 6. Yes, this is possible. Okay, so C is already out. Next, I look for the whether this is smaller than this. Okay. So remember, voltmeter 3 must be bigger. Okay, voltmeter 3 must be bigger. This one is the same as this. So this is out. This is bigger than this. So this is possible. This is the same as this. This is also out. So we already excluded this fella. So the only possible answer with 3 ticks is B. Okay, therefore the answer here is B. Okay, I'm going to pause here. Any questions? Okay, no one is saying anything. I'm going to assume that all is good. Okay, next, let's go on to the next question. Resistance of wire. Okay, so this is the original length, and this is the original cross-sectional area. Which of the wire has now half? Okay, this is half the original resistance. Now, in order to solve this, you must know that if the length of the wire increase, the resistance increases. Okay, so that's one, talking about length. Next, the cross-sectional area. If the cross-sectional area increase, the resistance of the wire will decrease. So this is the theory behind this question, okay? In order to solve this question, you must know this theory, this concept. Okay, so knowing that, let us now go back to the question. Remember, I want the total resistance to drop by half, okay? So now the wire length is increased, sorry, the wire length is decreased. It means that the resistance drop, which is good, which is what we want. But the cross-sectional area decrease. If the cross-sectional area decreases by also half, means the resistance increases. So taking this into account, the resistance of this fella is still 16 ohms, okay? Because drop by 2, up by 2, you're back with the original. Now let's look at this fella. It drops by 2 times, so the resistance also drops by 2 times. So now we are at 8, okay? We are at 8 ohms. Let's look at the cross-sectional area. The cross-sectional area is now double, okay? It means the resistance drops a further 2 times. Means from 8, it drops another 2 times, it now becomes 4. So the total resistance is now 4, which is not what we want. Okay, so this is out as well. Okay, this one does not change. So the resistance does not change as well. So now the resistance is still 16 ohms. The cross-sectional area decreases. If the cross-sectional area decreases, means the resistance will increase by 2 times. Okay, so therefore this is now 32 ohms. Okay, the original 16 times 2, because resistance increases by 2 times, which is also not what we want. So now let's look at D. Okay, so this one doesn't change. Therefore, the resistance doesn't change. It stays at 16. Now the cross-sectional area increases by 2 times, means the resistance decreases by 2 times. So 16 decreased by 2 times gives me 8, and the overall resistance now is 8 ohms, which is what we want. So the answer is D. Okay. Okay, guys, I'm going to stop here because it's almost 1 o'clock. So for the before I do a quick summary, are there any questions for the 16 questions I've done?
Question 15 is like confusing.
Okay, question 15. Okay, so step number 1, step number 1, you must know. Step number 1, you must know that the resistors across the voltage across 2 parallel resistors are the same. Okay, so that's 1. The voltage across 2 parallel resistors are the same. Okay, Teja, you got that?
Yeah.
Okay, so now voltmeter 1 and voltmeter 2 must be the same. Okay, so therefore I eliminated option C because voltmeter 1, voltmeter 2, here the option is different. So they must be the same. This and this must be the same. So option C is out. Okay, so I cancel option C. Now let's look at the next information that will help us solve this question. The next information is that this total resistance here will be smaller than this resistance. Very simple. I'm just going to put a number here. Let's say this is 10 ohms. This is 10 ohms. This is 10 ohms. Okay, I'm going to assume they're all three the same. If you press your calculator, 10 ohms, 1 RT equals to 1 over 10 plus 1 over 10. RT is going to be 5 ohms, okay? So the total resistance here is 5. Means that the voltage needed to cross a smaller resistance is smaller, okay? A small resistance needs small voltage. So this is the second theory, the concept that I'm using. So what I mean is, if this total resistance is smaller than this one, remember this is 5, this is 10, means the voltage for voltmeter 1 and voltmeter 2 must be smaller than the voltage from voltmeter 3. A bigger resistance means a bigger voltage. So knowing that, I look at voltmeter 3. This is 2, 2, 2. They are the same. It can't be. Remember, I told you this voltage needs to be bigger. Since they are the same, I will exclude A2. I look at D. They are also the same. 6, 6, 6. It can't be the same. So I'll also exclude D. And finally, I'm only left with option B. Okay, this fella is 4 volts, bigger than this 2, bigger than this 2. And it makes sense because if 4 volts drops here, it means what's left over here is 2 volts. to make up 4 plus 2 gives me 6. Okay, I hope that makes it easier for you to understand, Teja.
Yeah.
Okay. Okay, before we go, any other questions?
No.
Okay, now, once again, I apologize. I was late for today's class. I totally mistook the time. But for subsequent classes, I'll try and open up the room, hopefully 5 minutes before the actual class starts. So you help me tell your friends that I've recorded today's episode. Once the recording is ready, I will place it up somewhere. I'll let you guys know. Okay, Ken?
Oh wait, so where did you send the Zoom meeting?
Okay, so I sent the Zoom meeting details in the SLS to 4S2. The issue is, I don't think that your name and Ethan's name are inside 4S2, but don't worry, the subsequent meeting details, right? The login number and the password is the same as today's one. So you can just use today's login detail and password, Ken?
Okay.
All right. Okay, so if there are no more questions, I'm going to stop the meeting now. Let me stop share. I'm going to stop the meeting now. And then once the recording is ready, I will let your class know. And if any of you are still confused about today's class, you can rewatch the video again. Ken?
Okay.
Okay, thanks guys. I'm going to end the meeting now.
Bye-bye.
Bye.